Here are 11 reasons that you should learn to code. Firstly, you may want to automate some manual tasks. So you may have to open 1,000 spreadsheets and get the third number out of each spreadsheet and copy it to a new file. You may not want to do that 1,000 times, so you can automate that for yourself. You want to make something reproducible. So you can publish an entire research workflow from your data analysis, your data manipulation, creating figures, and everything in between. And you can give that to someone else and they can then reproduce what you've done. You can perform repetitive tasks. So doing something thousands, millions of times is quite easy. Billions, maybe not billions. Next one, format, manipulate, extract, transform, or clean your data. So you may get data in all sorts of different flavors with different configurations and different idiosyncrasies to it. And so having the ability to manipulate that data completely for yourself is really powerful. And you can process sort of larger data sets. So as soon as you open Excel, and I'm definitely not saying anything bad about Excel, it's an absolutely amazing tool. But if you find that you're getting the pinwheel, you've got 1,000 spreadsheets open, or just a couple pages, you've got sort of thousands of rows of data, it might be time to think about, can I do this in a more streamlined fashion? And that's where coding can be really powerful. If you want to simulate the world, so if you want to do something, that's what we do as scientists. We simulate physical processes. We take equations from textbooks and we want to put them into the computer and simulate them. So that's great for that. Extracting new insights from your data. Again, if you've got all these different data sets and different visualizations, sort of comprehending it can be too much. So pulling it together with some code and algorithms underneath it, that can be the way to do it nicely. New skills. You can learn new skills, have fun, and gain real independence for analyzing your data. And some things that are useful, if you need to use a specific code, so someone has done an analysis in a paper and they've published a code and you want to do the same thing with your data, then you can use that code and be able to reproduce their results on your own data or something. Or people around you are using a particular tool or code, then it can be very helpful to learn to speak the same language. And also a very overlooked one, coding is basically free. So it gives you access to a lot of open source and free tools and techniques and libraries and statistical workflows that otherwise cost money. So something like Microsoft Excel, it costs money, whereas R and Python, they're totally free. So you can do the same analyses without having to rely on paying for the software, which is great. All right, so let's go down and think about what exactly is a programming language. Whenever you are moving your mouse around the screen, you're clicking on windows and opening menus and clicking on buttons, there's only so many sort of things that you can fit on the screen at once. And so a programming language lets you kind of codify those instructions that you're giving the computer by clicking with your mouse. So fundamentally what a programming language is, it's a recipe or set of instructions for the computer to perform tasks. And that's what you're doing when you're clicking the mouse too, but writing them down in instruction format and computer programming format, you can sort of get access to a lot more instructions that may not be visible on the screen. And then those instructions, they're translated or compiled into sort of the binary and machine code, which lights up the correct electrons. And so, yeah, the binary transistor logic gates, they set voltages basically to positive or negative, and that's what's happening sort of at a very low level on the chips inside your computer. Yeah, so we go from circuit diagrams down to a very simple computer here with some sort of control logic, and then there's definitely a gray area for me if you know how it goes from this to a microchip. But computing instructions from a programming language, they tell you where to put the bits and bytes. And that's basically what a programming language is. And so to give you a brief history of things, back in the 40s, we had punch cards, which was basically ones and zeros. It was binary computer code. Each hole in the punch card represents some instruction. So if you have a one here and a one here, that might mean to add a one in this column over here, and so on. Then the next part, we went, hey, that's great, but it's kind of difficult. So let's look at this thing called assembly language. And this is where we came up with a sort of set of mnemonics, or like brief instructions, like move, pop, copy, to manipulate your data with a bit more control. And it really improved readability of machine language, but it was still rather difficult. So, this kid has successfully added 2 numbers in assembly language. Like it is quite a good task to do that. And there still might be reasons to write in assembly language. You can get really close to the hardware, and so you can write really efficient things, but it is difficult, basically. So we recognize this, and we invented higher level languages. And when we talk about low level and high level, it means low level is very close to ones and zeros, and high level is close to natural human speech and human language. And so, yeah, we basically abstract away for easier programming. And some familiar names there: Fortran, C, MATLAB, C++. They are in this group of languages. This is C++ code on the screen that adds 2 numbers together. Much more simple than sort of assembly languages. And then we sort of abstracted even further away into something called scripting languages. And these are basically, when you write in even a high level language, you still need to translate it and compile it down to the machine code. And a scripting language just sort of does that in the background, and you don't need to worry about that. So you get really fast iterative feedback. And so these have been really popular with, I guess, more casual coding and scientists, because they don't care about what's happening under the hood. They just want the answer. So that's why these scripting languages are fantastic for rapid development. It's the same adding 2 numbers together in Python, I think that is. And yeah, some familiar ones: Bash and JavaScript, and even PowerShell. So, alrighty. And at the same time, domain-specific languages evolved. And so these include things like SQL, which are built for databases, HTML, which we all interact with every single day, which is great for websites, and I guess is more of a domain-specific language for statistics, and also Solidity for interacting with blockchains. And the reason why you might use one language over the other is if you're writing a sequence of events, you have your data and you want to manipulate that data and get a result, that's a very different workflow to making something like a website, where you go backward and forward and click over here and then click over there. So it can be very sort of different paradigms to code in one language or over another. They have sort of different benefits to doing. Then we come to the future, where we have modern and emerging paradigms like concurrent and parallel computing, cloud computing, and distributed computing. And so languages like Go and Rust sort of take into account these modern challenges, but have many of the features that these older languages do, that are sort of closer to the metal. And then we get into things like quantum computing, which also comes with its own set of challenges and coding. And as we get into AI-driven code generation, so things like ChatGPT, we're even closer to be able to say, hey, computer, write me some code to analyze my data. It gets much sort of higher level language, which is exciting. All right, so that's the history. So which language should you learn? Let's have a look, shall we? Depends what you want to achieve. Do you want to extend or reproduce specific results? I'd recommend Python or R in that case. Do you want to do new analyses, perhaps? Again, Python or R. Do you want to simulate a particular physical process? For that, MATLAB, Python. Do you want to simulate every single physical process in a big climate model, perhaps? For that, you might want something with a bit more control, something like Fortran or C. Explore my data in more than just your mouse lets you. Again, Python. Or perhaps you've inherited a colleague's code and you have to use it because it's part of your research group. This is often the case. It will be in Perl or something perhaps a bit older. Do you want to make an app? In that case, you might use something like Flutter or Dart or C#. You may have heard of some of these, maybe not. Or do you want to make a website? In that case, some of these tools are not appropriate, and you're better off with HTML, React, JavaScript. You can do it in other languages, but yeah, it doesn't mean it's always a good idea. Or do you want do something crazy, like make a scalable data streaming service where people upload their Fitbit data to a website. Perhaps you have patients that upload their data, and then a clinician will run those data sets through a pipeline, and that will perform some analysis on it, and then a researcher will get their result and look at it and go like, oh yeah, this is good. We should feed this back to the clinicians to tell their patients this. And so in that case, yeah, the code that you use might be very different again. Also, who are you? You know, where do you see yourself in 5 years? Do you want to stay in academia? In that case, I'd recommend maybe R or Python. If you love this sort of thing, perhaps get into the tech industry and become a full-time developer. In that case, Rust, maybe Python, definitely, or maybe Java. Do you want to get into the big pharma? Then perhaps Bash or Perl would be more appropriate. A lot of their tools are written in that. You can become a business analyst, which can be very powerful. You may think that some of these occupations may not require coding, but they can be really helpful for, you know, analyzing results. So Python or something like VBA can be good. Or do you want to do some real specific job like the vivid light show coordinator, or perhaps, yeah, like a telescope operator, or something, yeah, very, very specific. In that case, something like C++, Rust, Python, you might have to dabble in all of those. Or do you want to work in a bar and you never want to code again? You know, that's also an option. And even then, you can benefit from sort of learning the logic that goes into coding, because all it is providing the computer with a series of logical steps. So if you want to make some cocktails, you can still benefit from understanding the logical flow there. In that case, I'd recommend Scratch, which is a great little tool. And who are you as well? So are you an undergrad? I personally first learned code formally with C++ as an undergrad. I think they teach Java as introductory computer science, and that can give you a really good understanding of you know, how computers kind of work and how the application that you're writing is interacting with the computer. But you know, maybe you don't care about that. Maybe it's your first day of your PhD and you just want to get your results. In which case, yeah, maybe higher level language like Python, R, or Julia. If you're towards the very end of your PhD, you've got a week before submission, then yeah, it's probably, I stick with Excel, or stick with whatever you're using now. Or are you a seasoned researcher? You know, then R or Python, or a specific domain. Maybe you're going to use Prolog or something bespoke like that. All right, so let's have a look at some industry trends for what's popular. And hopefully that context will let you stew over in your mind, you know, maybe what you're interested in. So this is the results of a survey that was sent out from, I'll just post this in the chat as well. So you can have a browse if you're curious. These were the results of a survey that was provided to, or given to, at Stack Overflow, which is probably the most popular forum for asking technical questions about programming. So if you search for like how to make a plot in Python, you'll probably get a result from Stack Overflow. And I think for this first question that I thought was kind of interesting, which is basically what's the most popular language, or what language do you use? There are 87,000 respondents, and JavaScript is number one, followed by HTML and CSS. So these together, basically that means websites. So people doing this, building websites. And then Python, number three, SQL databases. That's also very heavily related to websites, along with TypeScript there. And then Bash and Shell is very different. So this is probably more related to like Linux and system administrative things. Then we get down to the lower level languages like Java, C++, and C. C#, very different to C++ and C. That's more for like app development. And also Java and JavaScript are not related at all. So just keep that in mind. A bit of fun anyway. So they're the top ones. If you scroll down, you know, R is very popular, but you know, nothing sort of like the big ones. And you can get down to sort of some that I've never heard of before. Okay, so that is the most popular languages. And the other two links I bookmarked were the salary, which I think is probably important. So this is the salary on the y-axis and the number of years of experience that the respondent had made. So people who are just starting out and not earning very much, people that code in Dart, basically. So Dart is a relatively new language used for programming apps. And also if you're in app development, you don't get paid as much as someone who's programming in Zig. And I don't actually know what Zig is, but it is apparently well-paying programming language to know. And you probably don't have to have had that many years of experience compared to something like Delphi, which I think is like, yeah, I'm not sure what Delphi is either, but probably one of those older languages like mainframes. And surprisingly, doesn't pay that well. But something like Perl seems to scale nicely with the years of experience and the wage. You'll find R down here, and Python is not too far away. So a lot of new people, I suppose, and a fairly reasonable salary. So that's kind of interesting. And the next one I bookmarked was this. Oh, I've lost it. Oh yeah, here. I thought this one was worth pointing out is the salary by developer type. Now, if you code and you are a senior executive, you get paid very well. Then we see a lot of sort of engineering people, scientists. I think a lot of people on this call will be scientists, so that bodes well, that it's fairly well compensated. However, down here, this is a little bit concerning. Academic researcher is not paid as much, but hopefully in Australia we get paid a bit more than academic researchers overseas. But anyway, things to keep in mind and realities to face. So yeah, lots of interesting numbers to unpack, and also comparing these results from year to year, I think is quite interesting too. Okay, let's go back. All right, this slide is very confronting. Basically, if you go to search for Python on Wikipedia, it's going to tell you like in detail about what Python is and the difference between R and Rust. You don't need to worry about any of this. It just explains the details of exactly like the subtle differences between Python and C++ and why you might use one over the other. But when you're beginning, like, any language is fantastic. Python a little bit, I'm going to use the word easier than something like Rust, C++, or Java, but it's all contextual. So yeah, you don't need to worry about any of these languages, these words here, but they describe sort of how that language is constructed. So there's certain rules and syntax in languages that vary and change from language to language, which I said makes things easier perhaps or harder, which I'll demo in a second when you compare different languages. But yeah, you don't really need to know that too much. All right, let's try a live demo. So here we go. Let's look at some code. Okay, I'm going to open up a file called copper.csv. I'll open this in Microsoft Excel. Okay, hopefully everyone can see this. And so this has 4 columns of data in here. And I think that there's a couple 100,000 lines of code. I am on a fairly recent MacBook Pro, so hopefully it can handle that. I do remember the days when 200,000 rows of data was very formidable for Excel, but it seems to handle it well. And this is the latitude and longitude, so locations on the Earth of copper deposits, and the amount of copper that is in those deposits along with the age of those copper deposits. So that's what our data set looks like. And if we wanted to do something like find the equation of a line, do a regression analysis between the age and the copper, see there's some relationship there. We can do that in Excel there's about 1,000 ways to do it. But let me click all the buttons here. I'll send my instructions to the computer. I'm going to insert a plot. There we go. Select some data. I'll add you can time me if you want as well, because this will come in handy. The X values is the age, and the Y values is that column. So let's do that. Okay. And that's put me down the bottom. All right, so there's a little plot, and if I want to add a trend line, here we go, and show the equation. Okay, great. So there we go. I have it's very tiny, but 0.0 0.019 times the age plus 556 gives me the equation and relationship between copper deposits, the amount of copper, and the age of a particular deposit. So let's see if we can do this in a couple of programming languages and kind of compare the difference. Okay. So firstly, let's have a look at, what have we got here? Let's have a look at Python first. So this is the Python. Oh, sorry. Firstly, I'm going to do this. I'm going to go to ChatGPT and I'm going to write this this out. I'm going to say, okay, I'm going to tell it to write the code for me. So I'm going to say write code to load in a file called copper.csv and then find the equation of the line between the columns age and copper. So this is really high level, what could be called pseudocode. So you're just writing out your logic. And that's the beauty of these large language models like ChatGPT. You can write out your logic. And often by the time you write your logic, you know kind of the steps that you need to take in order to then go on and do the task you want to do, whether that's open it in Excel or do it in something like, it's written Python for me straight out the bat. And so there we go. We can see this chunk of code here. And it even explains, how this all works. And so I could copy and paste this into Python and hopefully it would work. But I did prepare one earlier just in case it doesn't. And in fact, it looks pretty similar. So every time you run something through ChatGPT, it'll probably look different. But this is Python. And so this is some Python code. It is fairly straightforward in what it is achieving. It's reading in that file, copper.csv, and then it's fitting in a line through those two columns, and then it's giving me the equation, and it also tells me how long it takes. So I'll click run, and we'll see how long it takes. There we go. It took 1.05 seconds to run that, but we got the same answer as we got in Excel, so that's actually a great start. All right, so I'm running this in my web browser in what's called a Jupyter notebook. Now this is very confusing, but there's lots of different ways to kind of interact with programming languages. And depending on the language, depending on who you are and how you operate, there can be different ways to do it. But this is one, and it's kind of fun because you can then keep writing Python code and continue on and make figures and make plots and everything. Now the next one, let's go to, it looks a bit different. Basically, everyone that uses a platform or what's called an interactive development environment, an IDE called RStudio. And I actually have some R code I prepared earlier. I could go back to ChatGPT and say, write this in R. And here we go. So it's going to write some code in R for me. Look at that. And that looks, I think, pretty similar to my R code that's already here. And it should do exactly the same thing. It is, what's this, about 20 lines or so. I think the Python one is fairly similar. And so if I run this, there we go. It took 0.2 seconds and said the equation of the line is 556 plus 0.0, approximately 19 times age. So I got a similar result out. And so Studio is really great. It tells you all these different data that is stored, and you sort of get a history of what you've done, and you can then go and modify this and say, oh, actually, I don't want the copper and age column. I want something else. So you can do lots of different iterations. You can explore your computer's files and system there. And if you save figures, you can look at them there. So RStudio is fantastic. Now the next one, let's go to ChatGPT and say, write this in C++. And here we go. Certainly. Below is an example in C++. And here it goes. So it's written it in C++. And it's actually significantly longer, and which can be concerning. And I can tell you now that C++ It's not the right tool for the job for this kind of thing, but it is a good use case. So here's one I prepared earlier. Now for C++, so here's the code. This one is around 80 lines compared to Python and R, which are about 20 lines to do the same thing. With C++, you have to actually also compile the code. So I have to write in this horrible line, which would take a long time to sort of figure out. But this is where it translates this text here down to machine code. And so Python and R, we don't have to do that, but C++, we do. Okay, so that has actually compiled it. Nothing's happened. You can see this is a little bit scarier to run. But then I can run it, and there we go, 556 plus 0.019 approximately. Yeah, cool. And it's taken about 0.116 seconds. There we go. So, and at the moment, I'm in another interactive development environment. This is called Visual Studio Code. You can run R in this, you can run Python in this, but yeah, there's sort of many ways that you can interact with these languages. And there were sort of 3 quick examples, all doing the same thing, all getting the same result. Some run faster than others. Some would be longer to write from scratch using a tool like ChatGPT. They can write them for us, which is fantastic. So, all right. So that was our Python code, our R code, and our C code. C++, yes, that one's much longer. Now, I've spoken about some of the benefits of languages. Often people go, oh, Python might be too really slow for working. And is Python really that slow? We saw that speed. I'll run through those results in a second. So is Python really that slow? Not really, but it kind of depends. There is a human cost to write it and also maintain it into the future. So if you want to keep things up to date, and also writing documentation and teaching people, there's all this sort of extra cost to things that may make a slow programming language like Python worthwhile using as opposed to something like C++. But that's just one benefit. So comparing these, yeah, the Python one took 1.1 seconds, I found. The R one took about 0.1 seconds, and the C++ one was just a little bit faster than the R. However, yeah, even if you're running them 1,000 times, it's probably not that slow. These were very rudimentary examples. You can make things sort of faster and slower in Python. Native Python is relatively slower than things like C, C++ compiled languages. However, you can actually use those fast versions in Python. So yeah, unless you kind of know what you're doing and you want to do something really specific and you must increase the speed of it, just don't even consider that at the moment. All right, so how do you get hacking? Well, let's go visit a few sites to see where you can get started with this. The first one I'd recommend is the very own Sydney Informatics Hub training calendar. I'll put this in the chat. And on here, you'll find various workshops. There's a couple, yeah, there's a course coming up for machine learning. And throughout the year, we post other sort of coding and training workshops that you can attend that are relevant to this. Come along to Hacky Hour if you have any very broad questions or specific questions that don't fit anywhere in particular. And a lot of these research essentials and experimental design, they're sort of code agnostic, but you can apply the same logic to very commonly to something like that. And yeah, we are more than happy to take on any questions that you might have. Now, the other place where you might want to go is NCI training. So NCI and Pawsey, they're the 2 national facilities that offer a lot of training. And at the moment, there's a couple of introduction to Gaudi, which will teach you all about Bash programming, and you can get down to sort of deeper things like OpenACC and CUDA and C programming as well through them coming up. They'll probably update more things through time. The next one was LinkedIn Learning, which is, see, can I post this in the chat? So LinkedIn Learning is something we have a subscription to through the university, and it's fantastic. There's a lot of great resources for tools like I think I've searched here, and for basically any programming language you can think of is probably available in LinkedIn, really high quality services. Also, YouTube and just the general internet has a lot of information. The other one that I have written down and recommend is the software carpentries. So I'm bombarding you sort of opportunities here, but they're all kind of different ways of learning and different ways of getting on board. So some people like to be told what to learn, others like to be self-paced, some like hands-on practices or videos. So there's all these kind of different options. Now the carpentries is basically built by researchers to learn how to code. So there's a lot of history and best practice that goes into developing these carpentries workshops. And a lot of people at the Sydney Informatics Hub are trained in the carpentries and sort of try and teach through the same mechanisms that the carpentries provides. And they have fundamental workshops like Unix shell, which is bash, Git, which I haven't mentioned, but it helps with coding. There's Python, there's R, and I think there's quite a few others extra. So there's the software carpentries, the data carpentries, and the library carpentries. All of those are good, and they're slightly different use cases. Okay, so I posted all those links, and I thought this was a neat little animation. Basically, I want to learn how to code. Let's do it. Motivated. Let's start with the basics. Here we go. Coding is super easy. I can do everything. I'm a complete hacker. I'm really excited. I'm so proud. And then things get, out of hand very quickly. And you can get overwhelmed after getting through the basics. And you think, okay, can I do this? Maybe. And you start to get annoyed with more complicated problems. And then all of a sudden things pile up and you panic. And you get overwhelmed with not being able to understand, and you go through the phase of despair. You go and look at other people's code, it looks totally different to your code, and you're like, how is this the same language? You feel helplessness, but then you realize that I do know a few things and I can code, and yeah, you should feel justified about being proud about learning a language, even though they can have a very steep learning curve and then several learning curves as you kind of level up and learn more things. So in conclusion, if you want to just get paid a lot, I guess go learn Zig. As I said, I've never heard of Zig before, but go for it. Learn Perl if you want to go and run your group's legacy code. Learn Rust if you really enjoy programming, I think. If you want to understand how computers work and everything, something like Rust, I think is a great opportunity. Most people at SAH, I think, answered Rust for what you want to learn. Learn R if your research group uses R. Learn Python if your research group uses Python. They're the recommendations that I make. So with that, I'll say thank you very much. We have a feedback here form for that I would ask. Oh, I didn't paste very well. I'll copy that. Copy that link. Let me try again. So yeah, we'll have. I would love if everyone could fill out a feedback form. Did that one work? Here we go. Okay, that's better. And that will take you to a page where you can just fill in how satisfied, how great this little workshop was. And feel free to recommend any workshops you'd like to learn. We'd love to hear your feedback of what programming languages and why also you'd like to learn programming. That'd be really cool. And we can potentially reach out. Now, if you have any questions, please unmute yourself and ask. Otherwise, thank you very much. And were there any questions in the chat as well? Scrolling back through. Thank you, Emily. All right, I don't think there's many questions. A few helpful tidbits added by people throughout the talk. So thanks very much for contributing. All right, thanks everyone, and farewell.